This Asus Vivobook is not charging and not turning on. Customer used it the last night and kept it in sleep mode. So today she tried to turn it on again. It was not switching on. So when she plugged it in, it was not showing charging light also. She thought it was a charger issue and she brought it to us for new charger. But when we checked the laptop with our charger also, it was not working. When we plugged it in and checked, it was not showing charging light. When we tried to switch it on, it was not switching on also. See, we are pressing power button and it's not switching on also. And we have seen there is no charging light, nothing. See charging light, no charging light. No, when we switch it on, it will turn the light. That light is also not there. We will open the laptop and see whether voltages are passing onto the board or not. See, we open the back panel. This is how it looks inside. We will check after plugging in. We will check whether 19 volts is passing onto the board or not. First, we will check the voltage at the charging port, whether the charger is finely connected or not. Sometimes, because of charging port issues, also voltage won't pass onto the board. We will check from the charger directly. See from the charging point, you can see the voltage 19.77. 19 volts is coming there. So let us see from this charging port to the MOSFETs whether it is showing whether the 90 volt is passing to the MOSFETs or not. Sometimes because of the track issues also it won't reach MOSFET. So we will check from charging port. Charging port is fine, 19 volts is giving. Now we will come to the sensing resistor. This is the sensing resistor. At sensing resistor voltage is not there. At MOSFET, input MOSFETs it is here. After first MOSFET it's not present. After second MOSFET also it's not present. And we'll check with the battery whether battery voltage is there or not. See at battery also voltage is zero. So battery also went into full zero mode. So now first we will check the resistance of the board on the primary 19 volt rail because sometimes generally short circuit happens on the 19 volt rail. Oh yeah, see there is short circuit on the 19 volt rail directly. That's why even battery voltage is also not present and the charger voltage is not passing onto the board. Let's check on the capacitors. Capacitor one side is 0 ohms and other side is also like almost 0 ohms, 1 ohms and 2 ohms, 0 ohms. It should be almost like kilo ohms or mega ohms. Sometimes it would pass to. Now we will open the board and see where the short circuit might has happened. Now the board is open. We will check the resistance on the 19 volt rail. In this type of things, sometimes there will be IC failures directly. There are hundreds of components are connected on the 19 volt rail. See on the input MOSFET side, the resistance is fine. After first MOSFET also resistance is fine. 0.44 mega ohms, zero point 0.4 mega ohms. At the sensing resistor, it's like short circuit 1 ohm. So mainly 19 volt rail is short circuited where the 19 volt passes to the majority of the components. You see at the capacitor 19 volt capacitor also it's 0 ohms resistance. Short circuit means we call it generally 0 ohms. The back side there is no 19 volt rail much components. So only we have majority of the components on the front side, all power regulators and all. And we will see any physically anything is burnt or something. Sometimes motherboard burnt marks will be there. Sometimes burnt components will be there. We will remove this heatsink also for the CPU so that it will be easy for us to troubleshoot the components. So 19-volt rail short circuit happens because of any failures, mainly because of sometimes capacitor failures. In little tough conditions, it will be like power regulators or MOSFETs. If it is power regulator failure or MOSFET failures, then it's going to be a complicated issue. You see here, this capacitor is looking dark. So what we have found is this capacitor failed. Capacitor, which capacitor failed, we don't know, and we don't know whether it is capacitor or even the power regulator. What why we are telling it's a capacitor is because the capacitor, when you see in this microscope TV, the capacitor has a very black color layer. That's why we are thinking that capacitor has failed. So when we inject power onto the power board also, you can see power supply. It's like almost with 1 volt also. 1 volt only. It's giving a short circuit current. So we'll put isopropyl alcohol on the capacitors and see which component failed exactly. In this region, we have so many capacitors and one IC is also there. So we will find which one failed exactly. See, isopropyl alcohol is kept on all the components nearby, and then we will inject the voltage. When we inject the voltage, see in the power supply you can see short circuit or 2.7 amps is passing, and you see the one capacitor alcohol is getting vaporized at one capacitor very fast, where the black color capacitor was there, black color mark was there on the capacitor. We will increase the current and see when we pass high current, then alcohol will get vaporized fast because of the heat generated. You see which capacitor is getting passed out now. You see that capacitor very fast. On that capacitor, alcohol was getting vaporized very fast. We'll zoom it in and show you, then you will understand exactly which one has passed. See, see, you see alcohol we are putting again on this capacitor, and see, yeah, it's getting vaporized very fast. You compare with other capacitors, this capacitor alcohol is getting vaporized fast. Yeah, so you can see when we zoom it in on the capacitor how fast it is getting vaporized. We are putting alcohol, and yeah, we are injecting voltage now. You can see started vaporizing, gone. See, out of all these components, only one capacitor, this capacitor's alcohol is getting vaporized near this capacitor. Luckily, only seems like this capacitor has failed because if the IC has failed or some other component, some other major MOSFET has failed, then sometimes it will become difficult for us to find the components also. So in this case, only this capacitor failed luckily. Let's hope this capacitor failed. After removing this capacitor, we'll check again for the resistance on the 19-volt rail. You see, capacitor became very bad also. Almost capacitor is damaged. And here we can't use a hot blower also because so many components are nearby. And one plastic capacitor is also there. If we put hot air blower, then that capacitor will get burnt. So we have to use soldering iron only for removing this capacitor. And it's very narrow. We will see which soldering bit is good for removing this capacitor. We will try to put solder on both sides so that it will be easy for us to remove the capacitor. First, we should put some lead on both sides of the capacitor. See, this iron bit is not able to go on the other side also. So we need to use the fine needle bit so that we can remove it easily. With this bit, it is touching the other capacitor. So we'll put little flux and use the other needle bit. See, this is the fine needle bit, so it will be easy for us to remove with this needle bit. And see, it is taking so much of time, so much of heat this is taking. Yeah, almost done. Done. See, it didn't disturb any other components also because of this fine needle bit. If we use hot air blower, that next capacitor will get spoiled. That's why we used the needle bit for this. Now we have to clean the flux and then we will test the resistance. So we initially only suspected something is wrong with 19 volt rail because it was not charging also and it was not giving charging light and it was not turning on also. It's called dead case basically. Motherboard is dead we call when there is no response from the motherboard. So we kept it in resistance mode and we will check. So here the sensing resistor. So you can see it's going to 356 kilo ohms resistance, around 300 kilo ohms. And the input MOSFET also it's fine. Next MOSFET also it's fine. Sensing resistor also. Yeah, it's fine. You can see now it's showing mega ohms. See, initially it was showing 1 ohm here. Now after removing that capacitor, it became fine. And see here we'll check on the capacitors also. See one side it's ground. Other side, yeah, it's fine 19 volt. Resistance is fine this side. So seems like that's the only capacitor failed. Now we will assemble the laptop and try to switch it on. It should switch on basically because 19 volt will pass now because it was initially a short circuit. So now we assemble it. Now we will try to switch on the laptop. Oh yeah, done. It got switched on. So it's a simple job. That's it. Done.